This video will cover section 10.2, Arithmetic Sequences. This will be the last section that will be included in your exam number 3. If you are watching this video because you were absent, make sure you stop by to get a copy of the review for exam 3, which will take place this coming week. We already went over the introduction, so what we were discussing is that arithmetic sequence, for example, this bar graph, it shows the spending on pets by year, and what happened is that every year they noticed that it was increasing by 2, and it's actually 2 billion, so that's a lot of money. And so arithmetic sequences have something in common. They will have a common difference being added or subtracted if that difference was negative for each term. So let's go ahead and look at the definition. And we have here an arithmetic sequence is a sequence in which each term after the first differs by the preceding term by a constant amount. So the first right there, it could tell you is different, right? So it will be either higher or lower, but it's going to be by a constant amount. So that's what I was telling you we will refer to as the common difference. Okay. Yes?
For the definition? Is
Oh.
that the definition though?
Well, that will be the formal definition, and then another one in simpler terms, let's write it down. So that will be a linear function. Remember, sequences are functions, but the domain, what is the domain for those? Is it all real numbers? Well, they are real numbers, but it's a subset of the real numbers. The set of positive, so numbers that are not like 1.2, 1.5. Numbers that you can count with your fingers. What is it? Integers. That's why we use the subscript, right? A sub 1, A sub 2, A sub 3. So the little subscript, that tells you the domain, which is the set of integers, positive integers. All right, so now we do have a general term of a sequence right there, and that's what kind of like what we were working with last time. And if you notice, what does the n and the n minus 1 mean? What does that mean? Okay, so if n minus 1, give me a number, Kimmy. If n is a number, 3. Then, Jesus, what will be n minus 1?
2.
Very good. So, for this sequence, the next term will depend on the previous term. Do you guys remember the name for those? It was on your notes. If you have them, you can look at them. It starts with an R. Yeah. Recursive, very good. Yes. So recursive. So this one, we're going to say that it's not only arithmetic, but it's also recursive. Very good, Cecilia. All right. So the question, write the first 6 terms of the arithmetic sequence, given that the first term is a 6. So I think that you guys can handle that one on your own, because it's just like what we did on Monday. So you start with your A1. I'll do the second one for you. So we need the previous one, which was A sub 1, and then we're going to add, in this case, a negative number. So that will be 6 minus 2, which is 4, right? Okay, so now you guys go all the way to A sub 6. I mean, yeah. Don't skip any. And I say don't skip any because it's recursive, right? Like it's single. So you have to find the one before you can get to the next. And you don't have to be so quiet just because I'm standing here. Speak for yourself. No, by 7th period. Oh my God. Those kids cannot stop talking.
I was told you were recording the video.
Oh, yes. But we keep talking. We kind of.
You didn't even stop the
I
recording.
didn't, huh? Okay, I'm gonna start writing my answers so you can check with yours, but if you're still working, please keep working on your own. And then if we don't agree, let me know. Okay, yeah, do we agree? So I got 4, 2, 0, negative 2, negative 4. Of course, since I had told you it is an arithmetic sequence, we don't even need to write all this stuff, right? Because we know that it's the difference is going to be 2, actually negative 2, so we're always going to be subtracting 2. Now, what if I had asked you find the 100th term?
I have a question.
Yes.
A negative. Oh, never mind. I thought it was like 2 minus negative 2, but then the negative 2 is like A, and you plug it into A.
Yeah, this one here?
No, it was like in the bottom.
On the bottom? Yeah, this was negative, because it came from here, and then negative, so negative. So what if I ask you guys find A sub 100? How long do you guys think it will take you? The whole class at least, right? Okay. Oh, well, since you know you're just subtracting 2, maybe you could do it faster. But it will be a little tedious. So, is there a better way? Of course there's a better way. Thanks you mathematicians, right? And so that better way comes from here. So with that one, with that formula, you'll be able to find any single term, okay? So now let's see why the formula works. So coming from let me see if I want to use the same sequence. Oh, I don't have a preference. So what was the first term of the previous sequence, Ruben? 6. Okay, so it's 6, 4, 2, 0, negative 2, and negative 4. That's okay. And so just keep in mind that the plus D, it just happened to be a negative constant, right? So we're just adding a negative number or subtracting, which is the same. So if you look at that, every term right there is going to have a minus 2. However, here, for the first term it's just 6. Second term you subtract 2. For the third term, you're not going to subtract 2. You're going to subtract 2 how many times? Twice, right? Because you're subtracting 2 times negative 2. For the next one, you subtracted 2 how many times? 3, right? So that's why we have here the plus 2D, plus 3D, plus 4D, and so on. So if we were to generalize that term, look at the 6th term. How many times do you subtract 2? 5, right? So if we generalize that and we want to find our A sub n term, or our nth term, in other words, then it will be the first term, and then how many times would you subtract the difference? Not n. Well, let's not think about 100 for a second, but we'll find the 100. Well, let's find the 100.
N minus 1.
Yeah, it is n minus 1. Very good. So you go one less, right? One less. So you notice here, to find the second term, you only subtract that once. Third term, you subtracted 2. So yes, very good research. You go one less, so n minus 1. And actually, that's the formula you guys have here.
Oh.
So let's see. If we want to find A sub 100, we will need the first term, and then how many times will we subtract the difference? 99. Very nice. Okay. So now with that, now we can use the formula because you know where it comes from. Now let's answer that question. So find the eighth term of the arithmetic sequence. So we're going for a sub 8. That's our question. Whose first term is 4, and the difference is negative 7. So using our formula right here, we're finding a sub 8. So we will need a sub 1 plus, how many times are we going to add or subtract the difference? 7. Very good. Is it negative 7? Well, actually, the negative will come here. Right here, and this will still be 7. Okay? So, but let's substitute. So this will be that, and then negative 7 plus, and then the first term was a 4. So we have 4 minus 49, negative 45. Thank you. And of course, you have to think, does it make sense? If you knew that the common difference is negative, would you say that the sequence is increasing or decreasing? Good, right? So it makes sense that the 8th term is a lot smaller than the first term, right? Yes? Okay. All right, let's go for the next problem. Next slide. Okay. Who would like to read this problem? Brista, thank you.
The graph in figure 10.4 shows the percentage of the U.S. population by race and ethnicity for 2010, with projections by the U.S. Census Bureau for 2050. The data show that in 2010, 64% of the U.S. population was white. On average, this is projected to decrease by approximately 0.45% per year. Write a formula for the nth term of the arithmetic sequence that describes the percentage of the U.S. population that will be white in n years after 2009. What percentage of the U.S. population is projected to be white in 2030?
Okay. And so I was talking to my algebra 2 students the other day about this because we're looking at exponential functions, so like growth and decay. And I told them that it was projected that by this year, Texas will turn from being a red state into a blue state. Did I ever mention that to you guys? Mm-hmm. And so that comes from the fact that the percentage of U.S. population who are considered to be white. Now here there's a little something weird. If you talk about race, the Latino community goes into white. But if you talk about ethnicity, then the Latino or Hispanics are a part of the white group. Okay? Okay, so it's kind of like we Hispanics are a subset of the white population if we talk about race. But if you talk about ethnicity, we're considered to be two separate sets. Yes? Are we clear on that? Does it make sense or no? Okay. So if you're doing a scholarship application and it's asking about your race, yeah. Of course, if you're other.
My mom says she puts other because she doesn't like being considered white.
She puts other. Okay, yeah, a lot of people do that. Okay, so then, in fact, last year, what was last year?
2015.
Then it was 2014. I could be wrong. But it was the first year where the white population, and I'm talking about ethnicity only, was less, the births were less, no, the number of births were less than the number of deaths. So that's when it made that switch. So now it's decreasing, okay? Another reason is because we have more mixed kids now, right?
Yeah.
So I think that could be another reason. Now that they're all dying. Okay. All right. So we're gonna look at this problem and answer the questions. So first of all, we need to come up with our formula, the nth for the nth term of the arithmetic sequence that describes the percentage of U.S. population that will be white n years after 2011. Now you can notice this is a little outdated, so maybe we could check we could Google what will be like the correct answer, no? To see if we're close. All right, so what was the common difference, guys? Do you remember? No?
45.
Okay, so we're talking, we don't want to give like how many people were of that ethnicity group, but we want to know percentages. So let's find the first one. So it says here in the year 2010, it was 64%. So let's consider our A sub 1, 64%. So instead of saying like 200 million or 10 million, we're just going to talk about percentages, okay? Oh, yeah. Okay. And so our difference, again in percentages, is going to be here, 0.45. But you guys see how it says decrease, right? So that means that our common difference, instead of being positive 0.5, is going to be negative 45. Very good.
Right when you said that we might leave early, she walked there. When you said we might end up leaving early.
Because it was too short?
Yeah, she walked in right after you
Someone's
said
leaving
that.
early.
Her hair was
I was like, he's having double digit.
No, she walked in afterwards.
She, like right after?
Yeah.
Yes.
Shouldn't it be 0.45?
That was a good question, and I remember last year I actually had to check the book because I wasn't sure. But yes, that was a good question. And what I ended up telling my students was like, I think that, oh no, and you're right with the 0.45. You're right. You know what? I was thinking 45%, so no, yes, you're right. And this is the one that I checked the book for, 64, because I didn't know if I should convert it to a decimal or leave it like that. But the book had it like that, just as a percentage. Okay, so then A sub 2 will be 64.
Yeah.
What's going on?
You were. So going back to our problem, we're going to go for 64%, and just so you know, there's no need to drop the percentage and convert this to a decimal. We will just leave it as a 64%, and that is because our vertical axis is defined in that way. So it's okay to leave it like that. Now, we're saying that after 1 year, it's going to decrease, right, by 0.45. So we're actually subtracting 0.45. Now, what we need to do is not get all the terms, right? What we need to do is come up with our own difference. So, not our own difference, but our own formula for the n term for this one. So, A sub 40. Oh, okay. We do have a specific year? Let me see.
It's 2010, then 600.
Okay. So here we're saying n is n years after 2009? Yes. Okay. So let me put it just with n, so you guys already know it's n minus 1, right? And then let's figure out what that will be. So we were saying that 2009, the year 2009 will represent n equals 0. And the year 2010 will be n equals 1, all right? And so that is why it says n years after 2009. So I think that for that one, we will leave it like that, just in general terms. And then that is the answer for part A. And of course, you could simplify, but sometimes it's just better to leave them that way. But now to answer part B, we're going to use that formula, and that's when we actually need a value right there. So we're talking about the year 2030. So if the year 2010 was n equals 1, 2030 will be n equals what?
19? Oh.
So it will be plus 20, no? Isn't it? Like the difference from here to here is 20 years?
Yeah.
So 1 plus 20, 21. Okay? So to find n sub 21, remember this is the one that represents the year 2030. And so that will be 64 plus 21 minus 1 times negative 0.45. And so that will give us the percentage for that. Now, I'm going to pause the video while you all get calculators. Oh, most of you have them already. Great. So I'm going to need you to check that. And then I'm just going to check with the book to make sure I did this correctly. So we get an answer of 55. Remember, we're talking about percent. So let's just see what will happen in the year 2050. I'm just curious. I want to know. Let's see if this will work. So the year 2050 will be n equals what? 41. So let's see if we want to find a sub 41. So that will be 64 times, oops, not times, but plus 41 minus 1 times negative 0.45. You guys get 46?
Yeah.
Yes. What is your question?
Let's just say we switch the formula to say what year will like the right race completely be reached.
That's a good question. We could actually find that out.
Yeah.
If we know that the decreasing percentage is 0.45 every year. If it was to remain constant, yes, we could. Let me see, where's our general formula? It was right here, right? And one thing that I didn't really mention is that we could actually do the following. We could simplify it if you want to. I think I mentioned, but I told you sometimes I don't. So if a sub n is equal to 64 plus, and then we distribute right here and here, it will be like, not plus, but minus 0.45 n, and then negative 1 times negative 0.45 will be plus 0.45. So simplified, it will be 64 plus 0.45, so 64.45 minus 0.45 n. So now, Sophie wants to do this question kind of backwards, so you want to know if this amount will be 0%. Is that what we want to know? Okay. So let's see if we can find that out. So what we need to do is just, we have like a linear equation, so yeah, we can solve for n and find out. So let's see. Here the 64.45 is positive, so if we take that across, it will be negative. That will be there, equals negative 0.45 n. And so right here, the 0.45 negative is multiplying, so we know we need to divide, correct? So can someone divide that for me, please?
143.2.
143.43.2.
Yes.
Okay, thank you, Kimmy. So that will mean 143 years after the year 2010. So 143 years. So that will be in the year 2153. So yeah. All right. So yes, that's a good question. Yeah, you could actually take the last term and figure out when will that happen.
That's if it stays constant.
If it stays constant.
We have like a
So
warp.
if it increases, then like they on.
Miss
Okay,
Nadia,
let's write the next definition. I had nothing to do with this. Let's write the next definition here. So the sum of the first n terms of an arithmetic sequence. And so an n partial sum is the sum of the first n terms of an arithmetic sequence. And it is denoted by a capital S with a subscript of n. So if we want to find the sum of the first 10 terms, it will be something like S sub 10. Or like the first 100 terms, it will be S sub 100. Yeah, are we clear on that? Okay, and now before we get to the formula, I want to tell you guys a really nice story that I love telling. It's related to math, I promise. So, so I'm gonna tell you guys a little story before we get to the formula that will tell us how to add sequences, and then we'll see if you can figure out the formula on your own. Okay? So, back in, I'm not sure what year, and it's not really confirmed. It's a little bit of like a myth, but we want to believe it's true. This little guy from Germany, Card Gauss, when he was in 4th grade, he was, of course, super smart, right? Super smart future mathematician. So the teacher was a little fed up with him because he was so smart. And so she wanted to give him a problem that will take him hours to solve. And so she told him, I want you to add the first 100 integers, positive integers. So 1 plus 2 plus 3 plus 4, and so on, until you get to 100. Okay? And so she thought, oh yeah, that will keep him busy for a few minutes or hours. So what was her surprise that he was so smart that he came up with this? And he said, well, if I write all the integers from least to greatest once, and then I do it again, and I write them from greatest to least, I skipped one, right? I skipped 99. That's going to be important, actually. So 98, it will be 97, right? And so the very last one, of course, since we're going from greatest to least, will be 1, and 2, and 3, and 4, and so on. Now, what he thought was this. If I add the first and the second row, what do you get here? 101. And here? 101. And here? Do you guys get the idea? Yeah. He actually discovered that he will get the same thing. So how many of those 101s does he have? 100, right? So he has 100 times 101, right? But since he wrote the numbers twice,
He has to divide by 2.
thank you, he has to divide by 2. Yes. Did that in 4th grade.
We're a little behind.
A little.
But of course, he was a genius, right? So what you see here, if I expand the 101, it will look like this. He did that 100 times, but he did it twice, right? So like they told us he had to divide by 2. And he got that by adding the first term to the last term, right? Like if you look at this one, it will be the same as if you say 99 plus 2. So that's why the general formula looks like that. And so you take, that was a nice story, wasn't it? So you take how many terms you're adding, that will be n. You take the first term, right here, and you take the last term. And that's how we're going to use it. All right? So right here it says a sub 1 is the first term, a sub n is the last term, and then n is the number of terms that we're adding. Okay? Yes?
Miss, I had a question for the test. Are you gonna give us those formulas or are we not? No, right?
Not that one.
What about the other ones for 6.7?
6.7 and 6.6. You know what? I don't remember. Let me see what I did last year. Let me refresh my mind. I think I gave some. Maybe not all, but some. From 6.6 and 6.7. But from 10.1, I don't think so. At least I really like this one. I remember when I took Cal 2, because like I said, you're going to use sequences a lot in Cal 2. My professor wrote it down, and he was like, who knows what this formula is for? And I was the only one who knew, because I was a tutor at UCC, so I was very familiar with it, so I was all right.
There goes Miss Seven again.
Of course. All right, so let's go to the next slide and actually apply the formula. So just so you don't forget, and we need to add the first 100 terms, so we're finding, let's just write it in general terms, it was n over 2, remember? He did that 100 numbers divided by 2 because he did it twice. And he was adding the first term with the last term. So in this case, our first term is a 1. So a sub 1 is 1. Now, we need to find the 100th term because that's the last term. So to find the 100th term, we're going to have to use the formula. And so that formula was the first term plus the common difference multiplied by, you guys remember what would it be?
Plus and minus 1.
N minus 1, right? So let's write it in general terms then. Just put n minus 1. Let's make this an n. So if we're trying to find a sub 100, it will be the first one plus 100 minus 1 times the common difference. Now, where is the common difference going to come from? And so that one comes from here. So what's happening from 3 to 1?
Plus 2.
A plus 2. Let's see if it's true. Is 3 plus 2 5? Yes. Is 5 plus 2 7? Yes. So we're right. The difference, you can find it by taking the second term and subtracting the first term. And so that's how we got 3 minus 1, which is 2. You might want to do it one more time just to make sure, like I did. So 5 minus 3 is 2. So just to verify. So now we know the D. A sub 1 is given to us. Right here is positive 1. Right here we need 99. And the common difference was a positive 2 because you notice the sequence is increasing, right? So it makes sense that the difference is positive. Okay, so here is 1 plus 198. So that will be 199. So that is the 100th term. So now for our formula that we have here, we're going to need the first and the last. We have them. And of course, we need the number of terms. So for the first 100 terms, we will have 100 divided by 2 times the first term, which was 1, and the last term, which is 199. So in this case, 100 divided by 2 is 50. 1 plus 199 is 200. And 200 times 50, that will be 10,000. Yes. So I'm going to retrace my steps, okay? So we started with let's count the right side as the last step. So this was step number 1. You acknowledged which one is your first term. And then to find, we did this to find the 100th term. We did all of this just to find the 100th term. This formula that we used, it came from what we were doing back here on example number, right here on this slide. Remember? We discovered how for the term number 6, a sub 6, you had to add the difference 5 times, which was 1 less than the subscript, right? That's why we used n minus 1. So that's what we did to find the 100th term, which is here. After we had that, we looked at the formula to add. Now this was a formula, so we had the first 100 terms, so that's why we have 100 here. First term was the one that was given, and this was the last term, the 100th term, the one that we found right here. So you apply the formula, and we got that answer. Okay, so I want you guys to work on checkpoint 4. So here is the answer of the checkpoint. So the first term was 3. The common difference was 3. You can see that how we found it here. And applying the formula to find the general term, we found the 15 term, which happens to be 45. From there, we went to the formula of the sum of an arithmetic sequence. And applying that, we ended up with 360. So let's go to the next slide. And now what we're going to do is find the sum of those terms. And of course, you might be thinking, are we going to write them all down from 1 to 20, from the 1st to the 25th? No, we're not. So what we're going to do is we could do something similar of what we've been doing. Let's see. Let's find the first term. So the first term will be 5 times 1 minus 9. So that will be 5 minus 9, that is equal to negative 4. Now let's find the second term. So 5 times 2 minus 9, so that will be 10 minus 9, which is 5. Let's find the third one. 5 times 3 minus 9, and that is equal to 15 minus 9, which is, you guys help me?
10 minus 9 is not 5.
Oh gosh. What is it?
1.
So, and here we get 4. Now, do we have a common ratio? Yeah, no. Isn't it plus 3?
minus 6.
4 plus 3 is not negative 1.
15 minus 9 is 6?
Yeah.
Okay. So from negative 4 to 1, if we say negative 4 minus 1, sorry, minus 1 minus negative 4. That's what we should do. So to find the common difference, you take the second term and then you subtract the first term. So that's why I have minus, and then the first term was negative. So this will be negative 1 plus 4, so it's still 3. Okay, now let's try a sub 3 minus a sub 2. So that, is this okay, 6? Yes? Okay, so 6 minus 1, and that gives us 5. So there's no common difference here, right?
So 1 should be 1 minus negative 4.
This was positive. So this is positive. So this is 5. So there's the common difference. Oh, okay. Thank God. Okay, so there is a difference. Okay. Sorry if I confused you, but if you just look at this part, a sub 2 was positive 1, and then a sub 1 was negative 4. So positive 1 minus negative 4. So that's why we get positive 1 plus 4, which gives us 5. So yes, the difference is the same. So we're going to say that D is equal to 5. Now, let's go ahead and find the last term that we need for the sequence. And that one will be which one? Which number?
25.
The 25th term, right? So a sub 25 will be a sub 1 plus, how many times are we going to add the difference? 1 less than the subscript, so that will be 24. Okay, so let's see. A sub 25 will be the first term, which is negative 4 plus 24 times positive 5. That is the difference. 16. Thank you. So 116 is our last term to compute this sum right here. All right, so formula again to find the first 25th terms is going to be 25 over 2. Think of n over 2 times the first term plus the last term, which in this case will be 25. And that's it, right? So let's see, we have 25 over 2 times the first term was negative 4, and the last term was 116. So in this case, we have 112. So here we could say 25 times 56. So what is it? 1400. 1400. Okay, very good. So that will be the sum of the first 25 terms. Okay, I want to see what's next here. So we're going to skip that checkpoint. Let's just solve this last problem. So your grandmother has assets of $500,000. That refers to the introduction paragraph. One option that she is considering involves an adult residential community for a 6-year period beginning in 2014. And so there's the model already. So the model describes yearly adult residential community costs and years after 2013. So here we're saying n equals 0 will be the year 2013, and n equals 1 will be the year 2014. Okay, it's just important to know those things. So does your grandmother have enough to pay for the facility? And she has this much. She has 500,000. So it's kind of like the problem that Cecily was asking us earlier. So let's see how many years. She wants to complete 6 years, right? Let's see if that will be enough. So
I should just plug in the 6 on the equation.
Yeah. The 6 in the equation? Yeah, well, that will be part of it. And then we will add them here. So let's find a sub 1 and a sub 6 by plugging in, like Jonathan said. And we can just do that because we already have the formula, right? So we don't really need to work that part for it. It's already there. So once you guys have found the last term, has anyone found it?
74,930.
So as you can see, adult residential communities are very expensive. expensive. Extremely expensive, which is a little unfair. So the first term was that. Okay, guys, so you can substitute everything in the calculator to get the final answer in even hand. You said that again,
22,580.
580.
She has enough though.
So she does have enough for a 6-year period. What will happen if she lives more than 6 years?
Then she'll be broke. Oh no.
I think she could cover for 1 more year. We don't have time to figure it out, but maybe you could find that out time. So this is the end of the lesson.
Let us